And we're going to do some notes. So I realized on that video the other day from the College Board, they were talking about algorithms, and I don't think I had defined the word for you yet. So I'm talking about it today. What is an algorithm? I Googled it, as could you. An algorithm is a process or a set of rules to be followed in calculations or other problem-solving operations, especially by a computer. So that's kind of a complicated way of saying it's how to do something that you've already figured out how to do. So it implies that you've figured out a series of steps to do something. For example, you probably don't have it written down. I hope you don't have it written down, but this could be an algorithm you follow for brushing your teeth before you go to bed at night. Get out the floss container, cut off a piece long enough to use, floss your teeth, get out the toothpaste and your toothbrush, apply the paste, brush teeth, rinse and spit, put everything away. There is an algorithm for taking care of your mouth at night. But I want to talk about a computer one now. So let's discuss a computer algorithm that we might use. What steps would we take to analyze a string and report back how many times a particular character showed up in it? So I'd like you to think about what you would do if I said, okay, write me code that tells me how many times this character shows up in that string. I mean, you don't have to answer me right now. Just think about it for a second. All right. So I wrote out steps. So let's compare what I wrote out with what you were thinking. So I got pretty specific. If I were going to do this, I'd create a count variable, put 0 into it, and then I would do a for loop starting at 0 and going up to the string length -1. And then I'd use the for loop variable and substring to get each character out of the main string. And then I would check if that's the character we're looking for. And if it is, I'm going to add 1 to the count variable. And at the end, I would return, or report what the count was. So that's an algorithm. And here's that code. Here's that program. So let's take a look. Make a count variable, put 0 into it, do a for loop, go from 0 up to the string length -1. Now notice I didn't say -1 here. That's because this says less than, meaning I is going to go 0, 1, 2, 3, all the way up to 1 less than the length of the string, because it's a less than symbol here. And then inside it says, hey, if the current character is equal to the target character, the one we're looking for, then we add 1 to the count. And then down at the bottom, it says return C. That would imply that we're in a method, or if we were just in code, you could print out C. I said it depends on the context, what the right thing to do here would be. Any questions on this? This is an algorithm that that you might run into. If I asked you to write code to look for a character in something, then this is how you would do that. Let's do another example. Return true. This says of, but it means it's supposed to be if. Return true if at least one letter of a string is uppercase. So see if you can think of how you would implement an algorithm if I asked you to write code to do this. I'm going to give you a piece of text and you're going to try to say if there's at least one letter in there that's uppercase. And then, I'll show you my way of doing it. Okay, everybody, I just went right to the code on this one. So let's look at the algorithm that occurred to me for this. I want to know if at least one letter in this string is uppercase. So I make a count variable. I made it 0. And I'm going to go through the whole string, right? Int I equals 0, I less than string.length. And then I pull the letter out just because I didn't want my code to be super complicated looking. So I just made a thing called a letter. And I'm grabbing the current letter. And then I'm saying, hey, if letter to uppercase is equal to letter not to uppercase, that means it's already uppercase, right? So we're checking, hey, if the uppercase version of this letter is equal to the letter, that means it's already uppercase. So then we just add 1 to the count variable. And then down here, I say, hey, if C is greater than 0, that means we found at least one uppercase letter. Otherwise, we didn't. Here's another way to do it. I made a Boolean variable called found capital letter equals, and I set it to false in the beginning. And then I did the same code in here, except if I found a capital letter, then I just changed the variable to be true. And then at the end, I just return the variable. All right. We got one
Mr.
more.
Hayes,
Yeah.
is there a reason why you couldn't just say if letter dot to uppercase, blah, blah, blah? Is there a reason you couldn't just say return true?
No, that's a third way you could do it. You could definitely just right here on this line say return true, and then down here you could say return false.
Okay.
Yeah, no, it's a great way to do it also. I was wondering if that was my next slide, since I just showed you like 2 ways to do this, but then yeah, I think that would be the third way I would show you to do that very same thing. So one last algorithm I want you to think about. If I asked you to reverse a string, so take a string and hand it back to whoever asked for it, but in reverse order. Think about how you might do this. These are all like little puzzles. So your task is to think, okay, how would I solve this little puzzle? So I'll stop talking for a second. Yeah, and you might just be like, well, I'm glad we got all these breaks today while Mr. Hayes stares off into space. Here is one way that you could return a reversed version of a string to someone. What I did is I made an empty string called temp. This is empty quotes. And then I did a for loop starting at the last character of the string, looping as long as I is greater than or equal to 0 and going down by 1 every time. And then just adding the current character to temp. So if it was the word book, it starts with the K, puts that first, and then an O, and then an O, and then a B. And then down here returns the temp. Anyway, this is an implemented algorithm for reversing a string. There's certainly other ways to do it. Questions or comments? I'm not making you dream this one up, but this is one that we did last week with Coding Bat, where one of the problems with the string 2 family problems was to figure out how many times, if the word cat showed up the same number of times as the word dog. So I just wanted you to see, here we are checking if we can find a string inside of another string. We did this already, the other day in Coding Bat. I just copied the code out and put it here to show you. Like that's another algorithm. Again, we're using a for loop to go through the whole string and then doing all this checking and counting. So the key with a problem like this is to make sure your for loop doesn't go out of bounds on the substring. So often you just kind of have to test it and see, because it's not super intuitive, but in this code, I circled the parts that matter with regards to that. Yeah, there's a lot of trial and error with this sort of thing, or writing out the words on the paper and giving it a try. But all right. So what's going to happen now is I've got an assignment called Day 34 Algorithms that I'm going to post, and then a few minutes after that, I'm going to post I'll assign the AP Classroom Unit 4 progress check. But I want to be really clear, everybody. There's 18 problems in the progress check. I'm just asking you today to do the first 9. And so you're not going to turn it in, or I don't know what the specific terminology is, but you're not going to like mark it as done, because then you would be marked wrong for the problems 10 through 18. And I just want you to do problems 1 through 9, and then slowly back away from your computer. I'm kidding. Just don't turn it in. Don't close it out. You finish it later. We'll do the other 9 problems. We'll probably do them on Friday. We have a little more material to learn before we do that. I did, however, along with the assignment on the Google Classroom, I post a video where I give you all the answers. So this is the case where after you do the 9 problems, you should open up my video, even if you didn't feel that you had questions. And at the very start, I show you all 9 answers. So then you could very quickly make sure you got them all right. And if you didn't, you could watch my video or ask a question. Okay. So, but the main thing is don't turn it in yet. So I'm posting at the algorithms assignment. It also has the slide deck on it. And then in a minute, I'll post the AP Classroom. Okay, so I've posted everything that we're doing today. There's the algorithms REPL that I hope you're working on. And then there is the AP Classroom nine questions. On the 9 questions on the AP Classroom, I'd encourage you to get a piece of paper handy and do some work on a piece of paper for the ones that warrant that. You know, some you might be able to do in your head, but the problems, you know, most of them, 1, 2, 3, 4, 5, 6 of them, I had little notes on paper. So don't feel like you should be doing it in your head. And if you're working on the algorithms thing and you're stumped, like it's not working, chat me and send me a link. I'll help you figure it out. So the first part of the algorithms REPL is a lot like some of the coding bat ones we did last week, particularly the one called count high was looking for the word high in a string, which is very much like what I'm asking you to do right here. If that helps. Bird just hit my window. That's so sad. It flew away though, so. Oh, it's a subtle part of part one, everyone, but I asked you to make it ignore the case. So you really need to just make everything either all uppercase or all lowercase up front. Make them both lowercase. So in a problem like part one, if it's not working for you, I would strongly recommend printing out the piece of text that you're looking at. And you can always add like a print call, and you'll see all these little fragments of text, and then say, oh, I can see why that's not working. Or, sometimes just printing something will help you see. I mean, it makes the output look confusing, but maybe sometimes it'll help. So I'd make sure your part one's working before you go on to part two. If it's not working, you could send me a link. Part two is like one of the problems that I went over in the notes, so you could look at the slide deck. Mr. Adair, I'm taking a look at yours. So if you're having any trouble, let me know. Send me a chat. Send me a link. It's 12:28. We got a half hour to go. So I did part two also. I'd say in my usual situation, if you had to if you had to totally just copy off the screen today, it might be worth trying again, like tomorrow, to do the algorithms assignment again without looking at the answer. See if you can do it on a fresh start. It's always good practice. All right, Meyer, I'm looking at yours. Um, all right, Marcus, I'm looking at yours. Thanks, Alonso. Shoot. Let's see, I stopped the wrong thing.